So these 2 points were our x-intercepts at 2, 0 and negative 2, 0. And these 2 points are the y-intercepts. They're at 0, 3 and 0, negative 3. Now we can connect these points with a smooth curve, and then we'll have our ellipse. So for our circle, we had equal amounts of x squared and y squared, and our radius was 6. So we started from the center and we moved 6 units left and right and up and down to graph that circle. Now for our ellipse, we're going to move 2 units left and right in the x direction and 3 units up and down in the y direction. These 2 points are the x-intercepts, and these 2 points are our y-intercepts. Now, there's an easier way to graph this ellipse than finding the x-intercepts and y-intercepts. Remember that this equation is the same as this equation, so let's graph this one instead. I'm going to get rid of this equation first, and now I'm going to write this equivalent equation in its place. We'll have x squared divided by 4 plus y squared divided by 9 equals 1. And remember that we're basing this equation on the Pythagorean theorem. So we can really think of 4 as 2 squared, and we can really think of 9 as 3 squared. We could have graphed this ellipse by looking at these 2 numbers. The squared number underneath the x squared term tells us to move 2 units left and right from the center. So since this is a 2 squared, we move 2 units to the right from the center and 2 units from the left from the center. The squared number under the y squared term tells us to move 3 units up and 3 units down from the center. This gives us our same 4 points, and we're able to graph our ellipse. In general, this is the equation we'll use for an ellipse centered at the origin. Notice that there's no number added or subtracted to the x or to the y. So the center will be at 0, 0. Now, what I've gone ahead and done is added this equation into Desmos, and I've created sliders or adjustments for the values of a and the values of b. Notice that if a and b are both 1, we get a circle centered at the origin. This is the idea that we'll have equal amounts of x squared and y squared, and the radius would just be 1. Now if I increase a, we stretch in the x direction 1 unit to the left and 1 unit to the right. This gives me an ellipse, since I have more x squared than I do y squared. And we could keep stretching our ellipse. We could have an a value of 3, an a value of 4, or an a value of 5. Since the a value is underneath the x squared term, that's the direction it stretches in. In order to stretch the ellipse vertically up and down, we want to adjust the b value. We can make the b value be 2, or 3, or even 4. And notice that if we bring it all the way up to 5, again, we'll have a perfect circle, since we have even amounts of x squared and y squared. This is why it's helpful to identify the a value and the b value to graph an ellipse. The a value tells us how far we should move from the center left and right, and the b value tells us how far we should move from the center up and down.